Alright, so just start up the video again. So, on this one, because n is some value, n cubed is a constant, it's fixed. So I can bring 1 over n cubed out to the front, and then all I have left is this, which then I can distribute. But then some of you are saying, well, both terms have a 6 in them, and the 6 is also a constant that's being multiplied by the variable, so can't I bring a 6 out there as well? And then I would have 6 over n cubed times the sum as I goes from 1 to n of what?
Let's just do I squared.
I squared
Minus I.
minus I.
Or can you
I know, yep. Which then you'll end up separating 6 over n cubed times the sum as I goes from 1 to n of I squared minus the sum as I goes from 1 to n of I. Questions on that algebra so far?
Oh.
What's the sum of I squared as I goes from 1 to n? That's what I've given you, yep. N times n plus 1 times 2n plus 1 all over 6 minus, what's the sum of I as I goes from 1 to n?
N times n plus 1 divided by 2.
Yep.
You can simplify if you want.
Absolutely, you're going to, yeah. How did you go about simplifying?
Foil.
Yep.
Foil inside.
I'll just do this first, n squared plus n. So you could probably do more steps, but questions so far? I'm going to FOIL this. 2n cubed plus n squared plus 2n squared, so that'd be 3n squared plus n. So help me remember that. N cubed plus 3n squared plus n.
Wait. Was it 3 or 2n squared? Yeah. Wait, isn't it? Wouldn't it be 2n cubed?
2n cubed plus 3n squared. Is that right?
Yeah.
Alright. So 2n cubed plus 3n squared plus n all over 6 minus, and then that one was n squared plus n over 2.
Yeah. You could get least common denominator, and then you could subtract those two before you FOIL that in.
I'm going to distribute first. But yes, you could. So this is going to be 12n cubed. I won't go too many steps here. I was gonna put each one over 6n cubed. Plus 18n squared
Plus 6
plus 6n all over 6n cubed minus 6n squared plus 6n all over
2n cubed.
2n cubed.
Divide by 6 on the first one. Divide by
I'm just going to separate them into 5 terms. So, 2, right? What's this?
3 and
3 over n plus, what's this?
1 over n squared.
1 over n squared minus, what's this?
3 over n. Or, yeah, 3 over n.
3 over n.
Oh,
And this. 3 over n squared. I'm going to distribute my minus sign as well. So 2, those 2 cancel. And then plus 1 over n squared minus 3 over n squared, so that would be minus 2 over n squared.
Yep.
There's your answer.
That would be fun.
What I did was I multiplied the second term in the boxes by 3 over 3.
Yep.
So I made them both over 6. Then I combined those.
Yep.
And I multiplied it by the outside. I think that actually made it easier.
Did you think so?
Yeah.
Yeah. There's, once you get to about right in here, there's multiple ways that you could go about doing it. So the sum of this function, as I goes from 1 to n, is this. Now if I said, okay, well what if n was 30? Put a 30 right there. What if n was 50? Put a 50 right there. Okay, you've done the work for if n is a variable. Now if I did ask you for a particular value of n, and where we're eventually going to go, there's kind of the key, that's what I wanted to get to by the end. So we're finding the area under a curve, and we're adding a bunch of rectangles together, right? We might add 2 rectangles together, we might add 3 rectangles together, we might add 10, we might add 20, we might add an infinite number of rectangles together. So what we would be doing, and here's the aha that I'd really like you to follow, okay? What you'll be doing is you'll be adding all these things together as n approaches infinity. So really all you'll do is find the limit of this, of your answer, as n goes to infinity. Well, what is the limit of this as n goes to infinity? 2. That's the idea of what we're doing in order to find the area under the curve. So just like with first semester, I'm going to give you this long limit algebraic definition of trying to find integrals, just like we did first semester with derivatives, and then we'll do shortcuts after that. But I want to give you the idea first. So,